This is TMUA 2021, Paper 2, Question 8. We're given P of x, which is a polynomial, a and b being real numbers, and b is bigger than a. We're given also told the statement star, which says that there exists a number c between b and a, such that the first derivative of p, evaluated as c, is equal to 0. And we want to determine whether p of a is equal to p of b if it is a necessary and or sufficient condition for star to be true. So let's first consider sufficient. So what does this mean? Well, this is precisely saying that P of A is equal to P of B means that there exists a C between B and A with P prime of C being 0. So is this true? So let's first analyse what this means. P of A is equal to P of B. So I've drawn on arbitrary points of A and B. And because P of A is equal to P of B, the polynomial P of x goes through both these blue points, which are both on the same horizontal line. So starting at x equals a, what could our polynomial do as you move along the x-axis a little bit? So either it could go up after x equals a and do something like this, or it could stay where it is and stay horizontal, or it could go down after x equals a and do something like this. But in all three of these cases, it must return back to this blue point. So the green curve must go back down after going up, and the black curve must come back up after going down. So what does that mean? So in the case of the green one, if it goes up and must come back down, that must mean there is a turning point somewhere along this range, which precisely occurs when P prime of x is equal to 0. So you must have a turning point in the green case, and the similar argument in reverse tells us that there must be a turning point in the third case as well. But what about when it stays where it is? This must, because it's horizontal, that means it has gradient 0 already, so it does already have P prime of x being equal to 0. So in all three cases, there is a value of c within B and A where P prime c is equal to 0. So it is sufficient. Is it necessary? Well, this statement means that there exists a C between B and A then such that P prime of C is equal to 0, then P of A is equal to P of B. This seems absurd because A and B could be anything. We could choose A to be minus 100, B to be plus 100, and if there is any stationary point in between that range, does that mean P of minus 100 equals P of 100? No, not quite. So it seems false. So what would be a counterexample for this? Well, one would be P of x is equal to x cubed, and with this has P prime of x being 0 at x equals 0, so c equals 0 works. And then we can just choose a and b to be anything. Why? Because x cubed is increasing, P of a does not equal P of b for any values of a or b. So it's not necessary. So the answer is C. The statement that P of A is equal to P of B is a sufficient condition is actually known as Rolle's theorem.